Okay, so find the derivative of the following function. This is the problem, and as you can see, there is a function on the top and there is a function on the bottom. So we can use the quotient rule. This is the quotient rule. If you have a function on the top and then function on the bottom, and if you would like to find the derivative, this is the rule you can apply. So find the derivative of the function on the top, put it here, just copy the function from the bottom, minus, copy the function from the top, times it by the derivative of the function from the bottom, and divide it by the square of the function on the bottom. In this problem, instead of function of x, you have function of g. So this is your problem. So I can name this the top function as function of g, f of g, and then bottom function as function of g, another name, z of z. And if I replace x by z, this is the quotient rule. So our goal is to find out the function derivative of the function on the top with respect to g, and then derivative of the function on the bottom, this one, with respect to z as well. So these are the value we are going to find out, plug the value, simplify, and that will be the our final answer. So as you can go down here, I have this function of z. I found the derivative of this function with respect to g is 6 by using the power rule, because the derivative of g is 1 and derivative of 7 is 0, so 6. And the derivative of the bottom function is, here you can see that this is square root of g, which is g to the power half. So when you try to find the derivative of g to the power half by using the power rule, that half comes here, and then g to the power half minus 1 gives you minus half. Because we have negative exponent, so if you have a negative exponent, you always bring that terms to the denominator, or you change the position of the term to make that exponent positive. So since it has negative exponent, by bringing this z to the denominator, it will be the positive exponent. We always change the exponent to the positive to simplify things. So now we have f of z, g of z, and their derivative. I'm going to plug this value back in this formula. So when I do that, so this is f prime z, this is g of z, minus this is function fz times this is g prime z. Since there is a 2 times square root of g, which is g to the power half, on the denominator, to combine these two terms, you should have same denominator. So what you have to do is you just have to multiply the top part and the bottom part by this common denominator, which is 2 times square root of g. So by doing that, now uh, as you can see, they have same common denominator on the top part, so I can combine them. On the bottom part, there is a square of this thing. So if we combine these two things, because they have the common denominator, I can just copy 6 times 2 is 12, square root of z, 7 is square root of z minus 6, minus 7, 6g minus 7. And on the denominator, there is a 2 times square root of z. And there is another function on the main denominator, which is 7 square root of g minus 6 squared. So we are going to apply this rule, which is if you have a over b over c, then you can write it down as a over b times c. You can multiply the denominator b and then c here. That is what we're going to do. Uh, so this 2 square root of z and then this thing here, we can write it down on the denominator. And now here we can use the distribution property. So we can multiply 12 times 7, that gives you 84. Square root of g times square root of z gives z. 12 times 6 is 72, and there is a square root of z, minus 7 times 6 is 42, z, negative times negative is positive 49. So to simplify, we just have to combine the like terms. Here you can see that this 84z and 42z, they are the like terms. So if we subtract 42 from 84, that gives us 42g, and rest of the things just copy it. And now finally this is what we got, and there is nothing we can do further. So this is the simplified form of the problem. So if we plug this value back in the problem, then that is what we are going to get as an answer.